My name is Usman Rangurekar and thank you for attending here. Sorry for the gate pass miss. But yeah, let's get started. Quick questions. How many of you have worked with AWS SQS or RabbitMQ? How many of you work with Kafka? Airflow? Nice. This will not be covered here, but knowing all whatever I mentioned will be helpful. So a quick disclaimer, if something goes wrong, I am not to blame. If what I say you repeat in an interview and you get kicked out, I am not to blame. Okay, so about me, I am currently working as a founding team member as a data scientist at ADAX. I have around 4 years of corporate experience, around 8 years of programming experience, and I am a certified Neo4j professional. In case you don't know about Neo4j, Neo4j is a graph database. So yeah. Okay, don't look at the agenda, no one does. Don't get scared. It will be bliss, don't worry. Okay, so let's tackle the business problem first. How many of you have worked in the domain of, say, advertising or something? Okay, first question, which should I ask? How many of you are students? 50%. Okay, nice. Okay, so the business problem is simple. It's related to displaying advertisements on your mobile apps, on websites, anywhere. Even when you are watching IPL or something. It's simple, though you cannot click that, but okay. So you have clicks and impressions. So impression is nothing but when an ad is displayed to you. That's called an impression. And a click is like when you click on it, either by accident or by intention. So CTR is something like you have 100 impressions and you got 10 clicks out of that, so your CTR is 10%. Why this required? Because the more the CTR, the more that ad should work, and you should display the ad to more number of people. So why do you need real-time CTR? I mean, I can easily get yesterday's CTR or last month's CTR, right? Well, think about it. Say there is a match going on. It's not going to last for 3 days, right? It might be some event is going on, some show is going on. It might last for only 1 hour. What I can probably do is like in the first 15 minutes, I can run A/B testing. I can get 3 to 5 cohorts of people and show them different ads. And in real time, if I compute which ad has a higher CTR, for the next 45 minutes, I will show that ad to everyone. I don't need to wait till next year to do the same. I can in real time decide what ad should I show to the rest of the people. So that's one of the use cases of real time computation. So why real time versus all batch processing? So batch processing is like you have data of last 1 week, last 1 month, last 1 year, and you take that data, process it together and write the output. But that's history. It's useful, but it's history. Streaming process is something that what is happening now. Like I said, what ad was clicked in the last 15 minutes? What is the CTR for this ad campaign? Okay, so we have a queue, one of the foundational patterns. You have a producer, you have a big queue in between, and you have a consumer. What happens to the queue is like you have multiple producers, but you can have only a single consumer because once a message pops from the queue, is gone. What is the benefit of the queue? Well, your consumer may not be there when your producer enters into the queue. You have FIFO, first in first out pattern, so you don't worry like your consumer is there or not. It's like a post office, but unlike post office, you won't get returns. Sometimes you might get if your consumer is not able to process the message. Okay, talking about queue, we have PubSub. So what is PubSub? Well, publisher subscriber, where you can have multiple publishers and multiple subscribers. So here, say a topic is kind of an event. Say we have a mobile app and we have a user sign up event. So I will maybe publish it in a topic events and give the event type is as a user sign up, and in the email ID I will give the email ID, name, phone number. Then this event can be broadcasted to multiple consumers. So I have an analytics service, I can have alternate service, monitoring service, etc. For my example, I can do like I can send them a welcome email like welcome to my website. I can start a web scraping bot to find if they are criminal. Anything I can do. In short, multiple things. So where Apache Kafka comes in. So Apache Kafka is kind of an holding area for your data. You should use Apache Kafka or anything in between as a buffer when your producer is generating data at a rate at which your consumer cannot consume the data. So if your producer is say producing the data at 1000 events per second, but your consumers can only consume the data at 500 events per second. If you don't have something in between, then you will lose those 500 events per second data. Also, if your consumer goes down at that time, the consumer rate of consumption is nothing but 0 events per second. So if your consumer is down for 10 seconds, you lose 100 events into 10 seconds. Also, Apache Kafka combines queuing and pops up through the clever use of consumer groups and partitions, but we won't get into that. Now, if you are using your holding area of data, like Apache Kafka, you don't want to lose your data. I mean, you are using Apache Kafka in case your consumer goes down. But what if Kafka goes down? Well, that's why Apache Kafka is distributed and fault tolerant. You have immutable and replayable logs. So you see these brokers here, broker 1 and broker 2, when they hold the same data. So if one machine goes down, the other has it. How does it have it? Well, we replicate. Also, in Apache Kafka, you don't replicate by machines. Like you are not saying that my broker 1 will be primary and broker 2 will be secondary. Like our databases, replication, primary and secondary. It's not like that. It is at the partition level, not at the machine level. So as you can see, I have a dummy users topic and I have decided my partition by myself. If the name starts with the first letter is between A to M, such as Ishan, I have a partition A to M. If there is a name starts from N to Z, then I have partition Susmit. So as you can see, the broker 1 is the leader for A to M partition, whereas the broker 2 is the leader for N to Z partition. This is because the producer always writes to the leader partition. And the consumers also consume from the leader partition, but if in case something happens to the broker 2, then I only have to make this the leader, not all the partitions. So we are safe. I mean, there is less work to do. Guys, please feel free to ask any questions immediately. Okay, so simple. This is what I mentioned about. We have a producer which is like, yeah.
Message queues can hold the events or messages.
Yeah.
So when we are using Apache Kafka, we are not preferring message queues.
So you can configure Apache Kafka both as a message queue as well as a PubSub.
Okay.
Yeah, I will take to your question at the end how you can do that. Remind me if I forget. Okay, so here we have a producer which writes to the topic campaign as. Based on the partition, you will write to the partition leader. Then it will get replicated to the other brokers. So you have partition 0 replicated, you have 1 leader and 2 followers. Each partition is replicated, so you have replica handling. So consumer groups. So consumer groups are nothing but your consumers in a group. Why? Well, because say you have a consumers of analytics service. You have a consumer for archiving service. Well, it does not need that you need only one consumer for each service. Like, I mean, if you have 5 partitions, why should your analytics service have only one node or one container which reads from all the 5 partitions? You can spin up 5 containers of the same service to read in parallel. So here I have 2 partitions, and for each consumer group I have 2 consumers. So consumer 1 from consumer group 1 is reading from A to M and kind of that. So in parallel here also. Just note that the partition can only be read by one consumer in a group. I mean, this partition cannot be read by both the consumers in the same group because there is no point. Big, yeah. So what is a stream? What do you guys think? Did you guys see any stream here while coming? Yeah, it's a stream. Bugs, sorry about that. Yeah, so this is a nature stream. I would personally like to code here all day, all once, but unfortunately or fortunately, all of us will at some point mess with the data stream and not the nature stream once in a year, every day, maybe even weekends. Yeah, so what is a stream? It is an unbounded stream of events. Taking an example of Netflix, till the movie ends, or the web series ends, or till your mobile data ends, you will keep on receiving the frames. Now, say you have to process that. Typically, you don't know when it will end. I mean, you don't know when the web series will end, technically. It depends on the processors. Also, say you have users or some anything data, you don't know. So now let's say I ask you a question, how many users do you have? How will you answer that? Because your users are coming in a stream, whenever user signs up, you get a sign up event which gets put into Kafka, queue up, PubSub, anything, then you consume it. So you have 1 user, 2 user, 3 users. But you cannot answer that question like I have 500 users, because while you are answering that you may get 10 more users. So how do you process the stream of events? Like what do you do? Simple, you box it. You just put multiple boxes over the stream of events, and then whatever computation you have to do, you do it for that box, and we call that box window. So I assume everyone here has done DSA, late code. Yeah, you have worked with sliding window pattern. You just have a slide window of size M and then a slide part of K. Sorry, it's been 5 years since I did DSA. Yeah. So you can just put it. So we have different types of windows. We have sliding tumbling window where you can have like a report of total is every 30 seconds. So what I will have that like 00:00:00:00 to 00:00:00:30, and then like this. So it will just tumble over the next window and then it will keep tumbling over. So whatever happens in that window, I will aggregate and put the result, aggregate or something. Then I have a session window. Session window is usually useful in your web applications because there is no time limit. Like working professional like us might like 1 minute, 2 minutes, 5 minutes. Students might be active for 4 hours. The session is session. It depends upon the user. So for session, you typically group by the session ID and you have an inactivity gap. So if the user did not do anything, say in last 2 minutes, then we can call that as a close of the session and we can proceed to the next window. Then we have a hopping window. Hopping window is like you have 5 events and after every few seconds you slide it. You don't slide it when something comes like stock market moving average. That's a sliding window. A hopping window is like you slide every time after a few seconds. So what is Apache Flink? What we talk about till now, first we talk about where our data will come. It will come into Kafka. Then we talk about, say we have a stream of events. We have 1000 events occurring at different events at times. How we will process, we will put them into windows. Then we will do computation aggregation. Who will do that? One of the things is Apache Flink. The second option is like you can have Kafka streams. You can also have Kafka KSQL. So basically you can do KSQL where like Kafka SQL where you can do the computation within Kafka cluster. But if it is very heavy, you have to launch a separate cluster of Apache Flink. So Apache Flink has its own cluster and not the cluster of Kafka. So first power is stateful. Now why do we need state? It's a stream of events, right? So why do we need state? Well, we need state because I am answering the question what happened in the last 30 seconds. So, or what happened in the last 5 minutes. Now, if I don't have a state stored, so where something to hold it, I won't know, right? Because if I see the data, I ignore it, it goes. I need to put it into some state so I can take a look at it after every 30 seconds. So that's why it's stateful. Exactly one guarantees it is a very rabbit hole. I won't go into that, but it uses checkpoints and other mechanisms to ensure that the output you get it at least once. Like you won't be in no output came, and you won't have to have duplicate handling at your consumer side. Like you won't get two outputs, same output after different times. There will be no duplicate. We have multiple libraries. We can use Java, Scala, but I am using PyFlink. So how Apache Flink works? Well, it's simple, almost like everything else. We have a client. We submit a job to a job manager, like your project manager. The project manager deploys tasks to task manager. Say you have two team lists. One team list task manager 1 and second team list task manager 2. Now each task manager has a number of developers in his command. So you have a client, you have a project manager, you have a team lead, and then you have developers. So whenever a client submits some task to the job manager, it gives the task to the task managers, and those task managers uses task slots to do the actual computation. I mean, job manager will do a little bit project management, timeline, etc. Team lead will orchestrate the task slots. The actual work, as always, will be done by the developers. So a quick recap of what we saw. We have two partitions, we have two consumer groups. Yeah.
So let's say for some reason one developer goes down, let's say he leaves the job. Now,
Yeah.
Does that data get committed if that job is done partially? Or
Yeah, so the answer to that question is that you won't lose your data, because what happens is that once in a while, after every interval, you have a checkpoint mechanism where what you do, whatever is in there, you take a snapshot of it and save it to disk. So if something goes down, you will restore the checkpoint, and from that last checkpoint you will redo the process. So if you have say processed you are working on a window from 10 to 10:05, and your Flink job, the one task goes down at 10:03, and the checkpoint happened at 10:02. So you have the data from 10 to 10:02, you have the computation results. After 2, whatever was to be done will be done again. It won't care like 2 to 3 will start only from 2. So by using the checkpoint, and you anyways have data in Kafka, right? If you don't act it, it will be there. Plus it is not a queue, so it won't go. You have a replayable log. You just have to change the offset back, and then you can process the data.
But if the window is large, then again that the checkpoint comes into the picture, because if earlier you have done maybe 100 tasks, and then at the 101 it fails.
Yeah.
Then you don't have to go back to the one again.
No, because you are checkpointing there. You are saving checkpoints. Like how do we do control as every few seconds or milliseconds, depending on how stressful the situation is.
Like checksums.
Yeah?
Like checksums. It's like checksum.
Yeah, no, not checksum. I say control S. So you like save it so it does not go away. And you maybe do even git commit. So each git commit is a checkpoint. Yeah. Yeah. So as you can see, we have two partitions here, right? So how does Flink work with? Well, if I have two partitions, I can launch two tasks in Flink. Each task we read from a partition. So it does not mean that I need only one task to read for both the partitions. I can in parallel read it, do simple map or filter. Map is like where you have to do transformation row wise. Like say you have a name, then take the first word, take the first name, you have the age or the date of birth, compute the age. That is a simple row transformation, right? You can just take one row and do it. What a column transformation is that you have to take into consider multiple rows. Say I need what is the average rate, the CTR, last 30 seconds. Now you have multiple users, so you have to aggregate that. So that's why what you do is that you have an operator where the data gets shuffled, and you ensure that for each group by, like you do like group by T, all the records pertaining to one of the key should be in the same node, as you cannot do aggregation. So that's what the key operator does, and then you have a sink where you write the data. So this is a source and that is a sink. Enough time. Now let's get into the problems. Like everything, even Kafka and Flink have some problems. They have smart ways to solve it though. Let's say we have a window of 10 to 10 3. Okay, a simple 3-minute window. The first event occurs after waiting for a very long time at 10:03. We are good, right? All agree that we have a event comes, like a JSON payload comes, where it has a key event underscore time, and the time there is 10:03 IST. So we are like, okay, our window is 10 to 10:03. We arrive a message where the event time is 10:03. All good. We just report to the database that hey, we have only one event, whatever it is. But after 1 second, a JSON payload comes which has a attribute event underscore time as 10 to 58. See, here we are not dealing with the processing time. We are not checking at what time did the JSON come. We are checking when was the JSON generated or what is the attribute inside. Now this can happen because of system delays, because of network delays, anything. There was a network delay, there was a network traffic. 1 second delay, it can happen. So what do we do? How do we know when to close it? Like when to close it? So what Apache Flink suggests is that you use something known as watermark. So watermark is like it is a saying that till now I am confident that everything has happened till 10:02. After some time I am confident that all the messages I have received till 10:30. Let me show you an example, it will be very clear. So here what I am saying that my watermark is 10 second delay, 10 second lag. So if an event comes at 10:00:15, my watermark will be 10:005. Like even if I get a JSON payload having the event time 10:00:15, I will consider that I have only received it up to 10:00:05. I won't say that I have received the event up to 15 seconds. I will say, okay, I have received only 5 seconds. So how does this work? It's like this. Say we have 10 second watermark delay and we have a 30 second doubling window from 10 to 10:30. The first event comes 10:15. It comes at 10:16 after 1 second. What is the max event time? 10:15. Watermarks minus 10, 10:05. Within our window, all good. Second event comes 10:25. It comes at 26. Max event time between this and this 25. Watermark what? It was 10:05. Now it is minus 10 of 25. 25 minus 10, 15. 18 comes at 27. This got massively delayed. But still the watermark of this, the max event time is still 10:25. So watermark will be till 10:15. Because the max event time, you just have to take the max of the event time. Now when the event comes at 10:42, we know that okay boss, till 10:30, like 10:32, everything has happened. So once we declare that okay, by till 10:32 everything has happened, we can close the window. Now, do you guys see any problem here? I will give you 30 seconds. This is how
user will say, like let's say if it's a stream of let's say live product.
Yeah.
And the frame will change. Like the one which you should have come earlier, that comes.
This typically does not appear to video playback.
Okay.
Yeah. It will be a very bad experience.
Yeah.
That this does not appear to video. This is for the analytics purpose at the back end. So you don't have any end consumer which is seeing the actual data. You have an end consumer which is seeing only the aggregate statistic. So let me repeat my question. Do you see anything issue there? This is a very good strategy, right? Whenever the event comes at 10:42, we do minus 10 and we know that 10:32 बज गए होंगे. So we can close the window. Well, the problem is Let me give an analogy, okay? Say in this room, we don't have any way to track time. Clocks don't work here at all. Clocks only work outside. And once you come in, you cannot go out. So, and I do not have any timer also. No software works here. And we are chit-chatting so much that no one in our head can count how much seconds it has been. So now I'm here, one attendee comes. The only way for me to know time is like that, just like he opens the door, I ask what is the time. The person looks at the time, tells me, and then comes inside. And now say I have to start this event at 11:15. It so happened that a person came at 11:14. I asked him what's the time, 11:14. We are all chit chatting. A person comes at 10:14:59. I asked what's the time, 10:14:59. Okay. Now I just want one more person to come. So I know that is 11:15, right? No one comes. All came on time. No one came late. All trains were on time. We are just waiting here. We are just waiting here because we don't know that it has been 11:15.
Whether the max event has achieved or not.
Yeah, because say this event did not come. A blackout happened across the globe. You have no users. So all you know that it might be 11 o'clock, but because you are like when watermark crosses 10:30, only then I will process. If no event comes, then you will be stuck. I mean, what will this will if this does not come? Right? You are stuck here. So there are two good ways to solve it. One is you can configure idleness. So unlike this hypothetical scenario, we do have their timer or stopwatch. We can just run a stopwatch after the last event comes and say, okay, I want the duration of 1 minute. So every 1 minute we just advance the watermark from the max event. Second is we do dummy watermarks. So here is my actual producer, and I have a producer made by myself named as heartbeat generator. Kind of how we check the health check status. Like I am alive, I am alive. They don't ask whether you are alive. You have to tell them you are alive. So it's like every kind of like that. So every 30 seconds I will emit some heartbeat message to Kafka, which will go to Flink. So if a blackout happens and all the producer goes down, and I am working on a power generator, but every 30 seconds a heartbeat message will come, and I will know that okay, itna bach gaya hoga. Let's proceed. So that's two ways where you can handle the scenario if no event comes. Like the source became idle. Any doubts? Then we have allow lateness. So what is the difference between watermark and allow lateness? Well, when we define a watermark, we don't say that event time we are extending. I mean, if my window is 10 to 10:30, my window is 10 to 10:30. Even if the event comes at 10:35, if it is an event time between 10 to 10:30, I will allow it because it is an event time. What is allow lateness? The event time itself is after my window, after the window close, and I don't want to put into the next window. So in Flink, we can also configure the allow lateness. So now what will happen here? Again, we are back to the same problem. How do we know when to close the window? Well, the solution is that we close the window when we are going to do. Let the event come when it comes. If we have a retractable sync, retractable syncs means, say you have MySQL database. You put a insert statements like from window 10 to 10:30, the 30 users came, 30 attendees came. After 5 minutes of the window close, one more event person came. Now MySQL suppose update statement. So you can simply run an update query to update your MySQL database. So that's a retractable sync. Now your downstream processes might be affected. So you have to decide whether you should allow lateness or not. Like once the window closes, you give the first result, and then whenever other events come which are late but within the same window, if they are within the allow lateness, you like emit the second result. You send an update. So I have a small demo for you guys. So what I did was I set up an end-to-end pipeline on my local using Docker Compose. So because I wanted to learn Go, then I created a dummy producer using Go programming language. It generates impression events and click events randomly with delays, intentional delays. I put them into Apache Kafka as a holding area. Then I have an Apache Flink PyFlink job which reads the strings and writes the CTR, computes the CTR to a file sync users.
So one question. Let's say you continuously keep adding event to the Kafka, but
Yeah.
Consumer is not processing this. Let's say your consumer goes down.
Yeah.
So it's supposed to process it.
Yeah.
And what happens? Does the Kafka has a limited memory?
No, so Kafka what it does, it has a memory plus it flushes to this.
Okay.
And it always writes to this also. And now it only depends upon your storage size. If you are on cloud and you have SQ storage, then it depends upon your budget configured in AWS. But you, and even if Kafka goes down, you don't have to worry because it is already replicated.
Okay.
So even if your local goes down and your consumer comes at that time, you have some or other local through which it can read. And you won't ever lose your data before it is written. And even after Flink releases it, Kafka still stores it. You can say it is a immutable, replayable log. Of course, you can configure the retention period. You can also configure the archiving process. Like I want last 3 months of data to be replayed, but after that just zip it and put it into some object store, if for later use. So you can also use it for audit logging if required. Does that answer your question? So the system is like we have Go producer, we have Apache Kafka, which generates 2 topics, 2 events and puts them into a respective topic, impression and clicks. We have PyFlink job and we have a file sync. Sync is nothing but the destination. By the way, the sync can also be another Kafka. So you can read from one Kafka, process it and add to another Kafka.
All to the same.
All to the same, but if you do to the same topic, then you are going to go bankrupt.
For the same topic.
Yeah. So what is the PyFlink logic? When I read from the impressions and click topics, I do a interval join. Now why do I mention the word join, interval? Well, when we do join, normal SQL join, what do we do? Just use the primary key and the foreign key. But here there are events and it will be never ending. So I need to put some bounds, right? From this topic for this 15 minutes compared to this topic this 15 minutes plus some certain delay of 15 seconds. Then we are grouping into the window or 30 seconds window. For each window we aggregate and then we write to a file sync. So let's say it in action. I have 2 options. I have recorded a dummy YouTube video, like I have recorded a YouTube video, or I can show it to live. Let's take a vote.
Like
Live.
Video.
Majority wins. Hope everything goes well. Okay. So let me just go give you a quick walkthrough of the code. You guys can see it? Yeah. Okay, so this is a typical Go programming language. We have impose, then I have a function which generates a random ID. My purpose is I am writing to 3 campaigns, so considering that at the time 3 campaigns are going on. So we have created a Kafka producer for 2 topics, impression and clicks. This is a custom class, so it will create a Kafka title for each of the topic which I mentioned. Then I have some generator configuration that I want 5 impression per second. There should be 25% click probability and the max click delay should be 10 seconds. Because you don't immediately, you first read, think and then click. Or some people read and click. Then I just keep a while loop. This is kind of, Go does not have a while loop, it has only a for loop which you can use an infinite while loop also. and then I am constructing an impression here. I am writing it, and here after a random delay, and if my click probability is within the 25%, I am generating a click event for that impression, which I am again writing to Kafka. So that's my producer. Let's go to the Flink table or Flink job. So first of all, I will set up the tables. Like you can declare your tables as source using SQL. So let's take a look at the couple of SQL queries. Let's take a look at the impressions table. So here what I am doing is I am not creating an actual table. I am define a source. So I have a table name as impressions, where I have impression as user ID, campaign ID, basically defining the schema of the data. How do I get that source? Like where will the data be? It will be in Kafka in the topic impressions, and the Kafka will be running at Kafka :9092. Then I have table clicks. So these are my two sources, and then I have my destination. So I have a table which is CTR by campaign ID, the window start, window end, impression clicks, what was the CTR, partitioning by the campaign ID, and I have a connector file system, and I will write to CSV. Either every 15 minutes it will roll over, or once the file size closes 1.8 MB, goes over 1.8 MB, I will write and then generate a new file. Let's go to the job. So here I am just like defining my impressions as from my table, from path, clicks. Then I am just renaming the columns. So campaign ID is like impression campaign ID, event time is the impression timestamp. You can guess it's written by LLM, but I fixed it, bug fixes. We have clicks, click ID, impression ID, event time. Then I do a join. How do I do a join? Based on the impression ID and where the click time is within 15 seconds. Like if you see your ad and if you don't click it within 15 seconds, I am not going to consider it as a click. It's up to you. It's up to the business. Once I have a join stream, I have a join stream, right? I have a stream of events which are joined together. Then I have to just put boxes over them. What are boxes? The windows. So I have window stream. After every 30 seconds, I have a window, and I am just on that join stream. I am creating a window stream, and then this is where the actual computation happens. So I am grouping by the impression ID for the window. For each window, I am grouping by the impression ID, impression and campaign ID, the joined one. I have the start, the stop, the campaign ID, the number of impressions, number of clicks, and then finally I am just selecting this, and here I am calculating the actual CTR, casting both to doubles to handle nulls or zeros if any, and then execute insert. And I guess here I am configuring the checkpoint, so every 30 seconds it will do a checkpoint. Now let's hope for the best and run it. Yeah, one more thing. I have created a simple run demo.sh because I predicted that you guys will ask for a live demo. So here I have a cleanup script where if something goes wrong, and this is very nice, I learned this for the first time when I created this project, crap.
Linux.
Yeah, Linux. The crap command I said. Yeah, then we have the root, the Flink, the PyFlink job script. I first start Docker compose up -d. I create the Kafka topics in case they are not there, and then I submit the Flink job to my job manager. So I have a job manager and I have Flink run, and I give the job dependencies like the Python script and the SQL script, etc. Let me show you the Docker compose file. So I have Kafka here. I am not using zookeeper mode, I am using kraf mode, where we don't know. I always use the latest stuff, bleeding edge cutting technology. So I am not using the zookeeper mode, I am using the Kafka mode, only kraf mode. So using the consensus protocol, it decides who will be the leader, etc., etc. It does not need someone monitoring them. And a single node because I am working on a local. Then I have a Kafka control center. I have the Flink job manager. I have the Flink task manager, and that's it. for the job task manager, I have a custom Docker file. So let me open the Docker file. So I took the Flink one. I need to install Python in that. Then I am installing Apache Flink. Then I am installing Jinja. Because I was going to construct the SQL dynamic. I was going to construct dynamically the SQL, and then I am just downloading the Kafka connector. This is like Flink SQL Kafka connector, via SQL I can in Flink, when I define the SQL I can connect to Kafka. So yeah, let's run it. My Docker is running. So OpStack is basically a lightweight version of a Docker desktop. Docker desktop takes a lot of memory. So yeah, the containers are started, the Flink job is submitted, and now we are starting a synthetic processor. So let's view the Flink UI and the Kafka Confluence Center UI. So here we have the Kafka control center. Let's look at the topics. We have two topics, clicks and impressions. Let's look at the clicks messages. So here you can see we have a click ID, the impression ID, the user ID, and the timestamp. This is the event time, and then we have the impressions here. Impression ID, user ID, campaign ID, timestamp. Then let's look at the Apache Flink job. So this is, as you can see, we are reading in parallel. One is reading from impressions, one is reading from clicks, topics. Then we are doing an interval join. Then we are grouping, calculating, and streaming file writer. And then we have commit. And let's take a look at this is the analytics, like how many bytes received, how many records received, how many bytes sent, records sent, etc. I guess we have to wait for around 1 minute for it to come. And we have checkpoints here. For like saving, and I just hope that it is writing. Let's check it out. So it should, yeah. Now I think it is like create output. I have created a simple Python script to read the results. I hate manual stuff. That's why. So I have I am using glob to get, based on the file pattern name, I get it, and then I construct the data frames and then read the CSV files, and once I have all the data frame I just concat them. So let's run it. Yeah, so we have today UTC time, window start, window end, the number of impressions, number of clicks, and the CTR. Looks like we have very awesome ads, and we click to it this one. Awesome, guys. Cool. Let's get back to the slides. So you can
go to the VS Code and show one of those file and produce a page.
Yeah.
What content it has.
Can you explain in layman terms like the whole process with an nice example?
Yeah, sure. I will come to that in the end. So yeah, this.
When we do this part process is completely on the temporary file, and
Yeah, so this is the file, it won't have headers. Right. You also need to remember that when you read by Spark, spark.read.csv, you have to mention header true or false.
So we are getting the time series data in that, right?
You can consider it as time series also. Time series is generally event time. This is like window start and window end. But you can consider the timestamp by taking the average, the middle midpoint, and then based on that.
Okay.
Yeah. So yeah guys, that's all. I will come to 2 questions remaining. Feel free to connect with me. This is a portfolio built in Next.js which has all my talks, all my projects, all my Medium articles. Yeah, that's it. And my work experience, etc. You can almost find me everywhere as Susmit PY. I will be uploading the YouTube video next weekend or this weekend for you to go through. Just the issue is the microphone is there. So yeah. Okay. I know 2 questions. I will just get to those 2 questions and then take up any more questions. Do you guys any more questions? Yeah.
About the so in this situation, do you pick Flink versus like any of the other alternatives? What are its strengths, weaknesses, compared?
Okay, so if you have a Kafka cluster and you are paying a lot for it, you will obviously do. Now, if you have basic transformations, you can get by K-streams, Kafka streams, and they are not much. It's easy to use by KSQL. If you have, if you have a dedicated compute cluster you want separation of concern, and it's massive, then you should use Flink. The strength and weaknesses depends upon your budget, upon your technical team, upon the time, and upon all the scalability in future, etc., etc.
What about when compared to like Storm, Spark?
So Spark also has streaming Spark support. You can also of course use that for Flink also. It really depends. You will have to hire a consultant, pay him.
So there's a one thing I want to add. In the Flink you get the real-time experience, but in the Apache Spark, you can say the micro batch. It's really low latency, but still the latency is there. So if you want near real time, so you can go to Flink. If you didn't care about that much latency, 1 to 2 seconds or something, then you can go for the Apache Spark.
Yeah, the micro batch point is crucial. Yeah. You had a question?
So my question is that as I've gone through everything you have mentioned, my question is that consider that I want to translate my current job in batch processing into using Flink. So my architecture design is as such that I have a correlation engine in between, which fetch the data from multiple different sources. Okay, now what I am currently doing is that we have some batch processing which works after every hour. Okay, I want to fetch that particular data as it is generated.
Okay.
I need to put it in my correlation engine.
Okay.
So the correlation engine, you can consider that it has a lot of large cluster of generative AI capabilities or something like that. I need to handle the token generation as well. So how can I do that using all the technologies you have talked about?
So first things first, question your decision, like do you really want to do that? Do you
Yes, I
really need to do
stream.
that?
Yes.
Okay, the second point is like you mentioned that in your engine you are fetching data from multiple sources.
Yes.
So put them into buffer first. Put up local Kafka. If it's small, put up persistent edit streams on your machine, so you can buffer your data, because things can fail and you don't want to lose your data. Then think if you a simple Python script which works every few seconds and just processes from Redis works. Forget our Flink.
Okay, so I should not use Flink in that.
I am not saying that.
Okay.
You should try to see if it works. Go
But
from
Redis will have delays, right? I need to run my script again and again.
you can in multiprocessing after every 1 second or 2 seconds depending on your throughput of your
That will
data.
actually give the computation cost more for running each and every script again and again.
Flink will cost you more.
So there's one thing I want to add. So you want it near real time still, right?
Yes.
Whatever is happening. So So you can just connect with the sync. The Kafka provides sync and connectors. So you just connect with them. So what you do, connect with the Kafka, whatever the processing you are doing in the Python or any language. I think all languages support the Kafka. So you just connect with the Kafka directly, and whatever the events comes into Kafka, you can do whatever the processing is. So
Yeah.
the easy way you can do it.
Yeah, with the Apache Flink, they're same Kafka Flink, but cost wise, you can carry that in.
There is a trade-off. Yeah.
Cautious. I mean, if you are very, then you can go with immediately. But else, consider alternatives first. That's why I say this technology is going big data. But first, see if you are in a big data or small data. Don't consider big
That's
data.
the most important thing.
Yeah, that is the most important point.
We'll take one more questions.
Okay, I just have to answer 2 questions.
I think if it's possible, you can take after this.
Okay,
Yes,
sure.
Just one more question is next one. Okay. That's great.
Thank you, guys.
Thank you for sustaining